Welcome to session on mathematics. We are in probability, and in the last session, that is session 9 and 10, we'll be mainly learning about another important probability distribution, that is using binomial distribution. Now again, in the binomial distribution, we'll try to evaluate the mean and similarly the variance. And after binomial distribution, we'll learn another type of probability distribution, that is Poisson distribution. And similarly, in this discussion of Poisson distribution, we'll see to obtain what is mean and variance. And at the end of this session, we'll learn another small concept in probability, that is geometrical probability. That is probability evaluated on a continuous domain where the events are not discrete like the discussion that we had till now. Let's proceed to understand what is binomial distribution. Now let's consider an experiment we repeated, say 3 times. Under similar conditions, we want to repeat the experiment for 3 times. Now in this experiment, we'll denote S as the event of success. Success is nothing but, or this is also called as happening of an event A which we wanted to evaluate the probability. So this event S is the success of happening of the event A. And similarly, as our usual notation, we'll say probability of happening of the event is P. Now similarly, we'll define F as the event of failure. Now what do we mean by failure? That is not happening of the event A. A will not happen. So we know that probability of failure would be 1 minus P. This 1 minus P will denote it by Q. Now once we have event, we need a random variable. Let X denote the number of successes. That means the random variable is the variable associated to the number of successes. As we are repeating the experiment 3 times, what are the different possibilities of X? Yes, X can take either 0, that is no success, or 1 success in the 3 attempts, or a success twice, or success 3 times. Now let's discuss the case of event of X equal to 2. Yes, can you tell me what is this event X equal to 2? It is the event of getting 2 successes in the 3 attempts that we are making. So X2 denotes the event of getting 2 successes in the 3 attempts in which we are repeating the experiment. Now, when is this possible? Yes, this is possible at... So what are the different possibilities of getting 2 successes in 3 attempts? Yes, maybe the first attempt is a success, second attempt is also a success, but the third attempt could be a failure. Or what is the other possibility? Maybe the first attempt is a success, second attempt is a failure, and third attempt is a success. Still we have 2 successes in this case. Or first attempt results in a failure, not happening of the event A, but the rest of the 2 attempts, second and third, might result in a success. So if you look at, this is possible in 3 ways. The event of getting 2 successes in 3 attempts is possible in 3 ways, which we can write it as 3C2 ways. Any 2 out of the 3 attempts is success. That is possible in 3C2 ways. Now let's observe what is probability of this event X equal to 2. Yes, the probability of X equal to 2 event, that is getting any 2 attempt success, is the probability of S, S, F, or S, F and S, or F, S and S. Now by addition theorem, this is probability of S, S and F plus probability of S, F and S, or that is plus probability of F, S and S, right? And again by multiplication theorem, this can be expressed as P of S into P of S into P of F plus P of S into P of F into P of S plus P of F into P of S into P of S. Now probability of success we assumed it as P, and probability of failure we assumed it as Q. So can we rewrite this as P into Q plus P into Q into P plus Q into P, which is 3 times, yes, P square into Q. Now this I am expressing it as 3C2 times P square into Q to the power of 1, that is 3 minus 2. Now look at this, try to understand this term. We need 2 successes to happen out of 3 attempts, so which can happen in 3C2. The 2 can be any 2 of the choices of 3 possible repetitions, out of which 2 are successes and the rest are failures. Now if you look at this term, this is one of the term in p plus q whole to the power of 3 is binomial expansion, isn't it? Now using the similar idea what I wrote here, can we express p of x equal to 1 now? Yes, it should be one success. Out of 3 attempts, any one success can happen in 3C1 ways. Success should happen with a probability p, so it is p power 1, and the rest 2 should be failures. So q repeats twice, that is same as writing 3C1 into p to the power of 1 into q to the power of 3 minus 1, right? Now these are the terms related to the expansion of p plus q whole cube. Now the probability distribution which follows such an expansion is known as binomial expansion. So let us first define this. A binomial distribution refers to a sequence of events which possesses what are the properties? The experiment should be performed under similar conditions for a fixed number of trials, like we have repeated the previous case for 3 times. The trials are independent, that is outcome of any trial does not affect the outcome of any other trial. There will be only 2 possible mutually exclusive outcomes in each trial, namely success and failure, for which small p denotes the probability of success and small q denotes the probability of failure. That q is nothing but 1 minus of p. Then if a random experiment satisfies these 3 conditions, that the number of repetitions are fixed and finite, and that each of the repetition trial is independent of the others, and the final outcomes are measured only with respect to 2 outcomes, that is either success or a failure, then the binomial distribution is the probability of x equal to r, where r successes are to be denoted. Let n be the positive integer and p be the real number such that p lies between 0 and 1. A random variable x with range 0, 1, 2, so on up to x is said to be binomial distribution, or also known as Bernoulli distribution, with parameters n and p if the probability of x equal to r is NCR into p to the power of r into q to the power of n minus r. If you look at x equal to r denotes the event of r successes. Now how is this term x equal to r? What is this event? Yes, is the event of r successes out of how many times we are repeating? Yes, n times out of n trials. How many ways can this happen? Yes, this can happen in NCR ways. Any r times we reach the success out of n such attempts to reach success. So which can happen in NCR ways. Then at these r places, success will occur at with a probability each time with p taken r times. Then what should happen to the remaining trials? Yes, there should be failure because only 2 possibilities should be there out of them. That means each with a probability of q so on. There will be n minus r times there is a failure. So when you look at this term, this is nothing but p to the power of r, and this is q to the power of n minus r. In each of them, number of ways of getting r successes is NCR. Therefore, probability of x equal to r is given by NCR ways, each with a probability of p to the power of r into q to the power of n minus r. Now what we are looking at, try to understand this. When we express p of x equal to 0, what does this event says? This is the probability of 0 successes in n trials, isn't it? How many ways this is possible? Yes, NC0 times probability of success not happening, so it is p power 0 into q, where all of them resulting in failure. Similarly, what happens if we write p of x equal to 1? Yes, this would give us the probability of, as an event, what does x equal to 1 denote? It is the probability of 1 success in n trials. Now this 1 success can happen in out of these n trials at any one place in NC1 ways, into 1 success can happen in with the probability p, and the remaining n minus 1 attempts with failure each with a probability of q. So it will be the total probability of x equal to 1 would be NC1 into p to the power of 1 into q to the power of n minus 1. Similarly, let's write one more and then we'll generalize. What would be x equal to 2's probability? It is the probability of, yes, how many successes? We have associated a random variable 2. That means it is 2 successes in n trials. Now these 2 places where success should happen can be any of the n places in NC2 ways. At each of them probability happens with p, so 2 of them p into p, that is p square, and at the rest of n minus 2, the failure will happen with a probability of q each. So q into q into q taken n minus 2 times. So written like this, if you observe one important property here, p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2, so on up to p of x equal to n, that is the total range values of the random variable. How will be the sum here? Yes, it is nc0 p to the power of 0 into q to the power of n plus nc1 into p to the power of 1 into q to the power of n plus 1 plus nc2 into p to the power of 2 into q to the power of n minus 2, so on. What would be p of x equal to n? Yes, out of n trials will be successful in NCN ways into success happening n times, so with each time with a probability p, and failure not happening at all, so it is q power 0. But if you observe these terms, yes, this is nothing but the binomial expansion of p plus q whole to the power of n. But what is p plus q? P is the probability of success and q is the probability of failure. So this is 1 to the power of n, right? So sum of all the individual probabilities is happening to be 1, and each of these events is having probability given here. Then this will also denote a probability distribution of a random experiment with the random variables possible as 0, 1, 2, 3 up to n, each having a probability where the rth event has a probability of ncr into p to the power of r into q to the power of n minus r. Then the sum of their probabilities would be 1, hence this denotes a probability distribution, right? Because it is following a binomial expansion, this is also called as binomial distribution, and as it is suggested by or developed by Bernoulli, so it is also known as Bernoulli distribution. Now for this Bernoulli distribution, let us observe how is the mean and how is the variance. Now when we wanted to calculate the mean of this random distribution, what is by definition the mean of distribution? Yes, it is sigma I equal to 1 to n, the random variable into probability of the random variable x equal to xi. Now what is random variables here? Let us say r runs from 1 to n. Random variable is r and the corresponding probability of x equal to r. Now just now we have seen how does binomial distributions probability of x equal to r define. Yes, it is r equal to 1 to n, random variable r into probability of x equal to r, ncr into p to the power of r into q to the power of n minus r. Let's use the simple properties of binomial expansion to get this sum. Yes, it is sigma r equal to 1 to n r into this ncr, we will express it as n by r into n minus 1 c r minus 1 times p to the power of r minus 1 into p into q to the power of n minus 1 minus of r minus 1. Look at them, no place the value is been affected. Now which are not affected by r, let's pick the terms outside. What is remaining? Now n comes out of this expansion and the p which is taken out separately comes out of, and what is the remaining expansion now? This is sigma r equal to 1 to n. Yes, r and r gets cancelled, leaving us with n minus 1 c r minus 1 p to the power of r minus 1 into q to the power of n minus 1 minus r minus 1. Now look at this term inside the sigma. Yes, that is again a binomial expansion of n into p into, yes, this is p plus q to the power of n minus 1. But as p and q are the probabilities of success and failure, their sum would be always 1. So this is n into p into 1. So what is mean of the binomial distribution? It is the number of times the experiment is repeated into the probability of happening of the event. So n into p denotes the mean of the binomial distribution. Similarly, when we wanted to calculate the variance, here also we'll use properties of binomial expansion. So when we want variance square, let's see how is this by definition. This is sigma, say r equal to 0 to n, xr square into probability of x equal to r minus of the square of the mean, right? Let's replace these values here. This is sigma r equal to 0 to n, xr, what is this random variable here? Yes, the number of times the success is repeated, so it is r square into what is probability of x equal to r by binomial distribution? It is ncr into p to the power of r into q to the power of n minus r minus mean just now we have calculated. It is np whole square. Now look at the first term here. r square into NCR into p to the power of r into q to the power of n minus r when we use binomial properties NCR. So look at this first term r square. Can we rewrite that r square as sigma r equal to 0 to n summation? R square we'll write it as r into r minus 1 plus r, so that minus r cancels with plus r. The remaining terms we repeat as it is, NCR into p to the power of r into q power n minus r. Now let's split the terms with the first term here in this bracket. This would be sigma r equal to 0 to n r into r minus 1 into that NCR which we have here. We'll replace it with n by r into n minus 1 by r minus 1 times n minus 2 cr minus 2 into p square into p to the power of r minus 2 into q to the power of n minus r. Till now we expanded with the first term. Plus, how is the sigma on the second term? Yes, it is sigma r equal to 0 to n r into NCR into p to the power of r into q to the power of n minus r minus this mean square is term remaining as it is. Now look at the first term which are unaffected by sigma. Let's bring them out. N minus 1 and p square are unaffected by the sigma, so it is n into n minus 1 into p square as it is. Look at the remaining terms. As we have r and r minus 1 gets cancelled. Now the summation starts from n minus 2 cr minus 2. So let us begin the summation with r equal to 2 to n. Yes, n minus 2 cr minus 2 p to the power of r minus 2 into q to the power of n minus 2 minus of r minus 2. This is same as that of q to the power of n minus r. Plus, look at the second term. This is r is a random variable and NCR into p power r into q to the power of n minus r is nothing but the mean of the distribution. So this is nothing but np minus the last term as it is np whole square. Now look at the first term. Sigma r equal to 2 to n minus 2 cr minus 2 p to the power of r minus 2 q to the power of n minus 2 minus r minus 2 is the binomial expansion of n minus 1 into p square times this is nothing but p plus q to the power of n minus 2 plus np minus of np whole square. Now what is this value? As p and q are the probabilities of success and failure, this is 1. So what are the terms remaining now? N square into p square minus of n into p square plus np minus n square p square. So when we remove these two terms and take n into p common, remaining is 1 minus p. But what is 1 minus p? As p is the probability of success and q is the probability of failure, 1 minus p would be q. So this is np into q. So what is the variance of a random binomial distribution? It is n into p into q, that is number of times the trial is repeated, into probability of success into probability of failure would be variance, whereas the mean is n into p. So we are able to calculate the mean and variance of a binomial distribution also. Mean is n into p and variance is n into p into q, right?